Alrighty guys, how's it going? What we're going to be doing today is we're going to be solving this system of equations using a matrix. Now what you're going to find is that it's very similar to how we go ahead and use elimination. So with that being said, let's go ahead and jump right on into it. The first thing you got to do is we need to go ahead and draw our bracket, okay? Now what we're going to put inside the brackets is our coefficients, okay? Now the coefficients, just a refresher, is the number in front of the variable. So looking at our first equation, you'll notice for x, it doesn't look like he has a number there. But technically he does. It's the number 1. So we're going to put a 1. Same thing goes for the y. We have a 1. And for the z, since it's a minus z, I will have a negative 1. And then, of course, the number off to the right-hand side of the equal sign. Now let's go ahead and do the same thing for the second equation. I have a 3, a 2, a 4, and a 17. And then last but not least, the last and final row, we got a negative 1, a 5, a 1, and an 8. And plugging our system of equations into the matrix is typically not the hard part, okay? And it's actually pretty straightforward. But make sure you listen very carefully to what we're about to do next. Now, like I said, we were going to see a lot of similarities in this matrix problem from elimination, okay? Because the idea when using a matrix is we want to look for the same numbers but opposite signs, which is what we talk about all the time when using elimination. So what you'll notice right off from the get-go, okay, and actually before I start going into that, I should start with this. The ones we're wanting to eliminate, okay, because we're not just trying to eliminate just any set of numbers, we're trying to eliminate these three, okay? Our goal is to see these three numbers become zeros, okay? And so in order to do that, now moving forward, we want to make sure that across from them, they have the same numbers but opposite signs. And you'll notice right away, okay, looking in our X column, okay, you'll hopefully see that we have a 1 right here and a negative 1, 1. That's going to allow me to, when I add the first row with the third row, I'll be able to eliminate that green one, okay? So let's go ahead. I'll go ahead and also label the rows for now. So this is row 1, row 2, and row 3. So when I'm referencing them, that's what I'm talking about, okay? I'm talking about these rows. Now, like I said, I want same number, opposite signs, so let's add them together. So I'm going to take row 1. I'm going to add it to row 3. Now, what I'm going to go ahead and do is say, where is negative 1 located? Which row? Well, he's located in row 3. So I'm going to say all my solutions that I'm about to find, I'm going to place them in row 3. Now, let's go ahead and start drawing our next matrix because we're going to want to plug some values in there before we start solving. The values we're going to want to plug into the next matrix is the rows we are not eliminating from. So we're not eliminating anything from row 1. Yes, we are using row 1, but I'm not eliminating any values from it. So I'm going to write it. So I have 1, 1, negative 1, 4. Row 2, I will eventually eliminate from it, but I'm not doing it currently right now. So I'm going to write the numbers 3, 2, 4, and 17. Now, I am eliminating from row 3, so I will leave it blank, okay? Because you'll see right now, underneath it, okay, we're going to go ahead and plug our numbers into this equation, okay? Because what I wrote underneath this matrix, okay, is the process for solving the next row 3. So let's go ahead and see. So in row 1, just kind of start things off, I have 1, okay? In row 3, I have negative 1. Well, 1 plus negative 1 is going to be 0. Now let's look at the next number in row 1. It's another 1 again. And then we're going to add the number across from that, which is a 5, okay, in row 3. So I have 5. Well, 1 plus 5 is 6. And then I have a negative 1 now, plus 4. No, my apologies, not 4. it's going to be 1, right? 1. And then negative 1 plus 1, that's going to be 0. Okay. And then I have one more to do. I've got 4 plus 8. And that's going to give me 12. So now what I'm going to do is I'm going to take these values, okay, that I just solved for, these ones right here, and I'm going to place them in this row, okay? So coming back to this, I have 0, 6, 0, and 12, okay? So I accomplished my goal. I went ahead and I eliminated one of those zeros, okay? But my objective is still out there. I need to go ahead and get rid of this 3 eventually, and I still need to get rid of this 6, okay? I still need to make these 2 points a 0. So let's keep going. So push this on over. And now let's go ahead and eliminate the 3 from that row. Now, what I'm going to go ahead and do, okay, is I'm going to go ahead and take row 1 plus row 2. Okay, now where is that 3 located? Well, it's located in row 2, so I'm going to put it's equal to row 2. Now I'm going to go try to snap back to the color that I've been using. Okay, I'm going to go ahead and plug in what I'm not eliminating, right? So I'm not eliminating anything from row 1. So I'm going to go ahead and write row 1. So, but yes, though, I'm using it, but once again, I'm not eliminating from it. Okay, there's a difference. So I've got 1, 1, negative 1, 4. And then row 3, same thing, okay? Not eliminating anything from it. So I've got my 0, 6, 0, 12. But I am eliminating something from this second row, okay? So I'm going to leave it blank. Now looking at this right here, if I were to add row 1 and row 2, 1 plus 3, that's not going to eliminate, right? That's going to be a 4. So we need to go ahead, like in elimination, we need to modify row 1 so that way it will eliminate. So what could I do to this row 1? Well, I could multiply it by negative 3. Because if I do negative 3 times 1, then add row 2, I will get a 0. And so that's what I want, right? So I have to do this to each row, though. So I have negative 3 times 1 plus 2. That equals negative 1. And I have negative 3 times negative 1 plus 4. That will be 7. And negative 3 times 4 plus 17 is going to be 12. Not 12. My apologies. 5. There we go. Boom. So negative 3 times 4 is 12. Negative 12 plus 17 is 5. There we go. So now, what I'm going to go ahead and do is I'm going to take what I just solved, this stuff right here, okay, all this stuff, and I'm going to plug it into this row right here. So I have 0, negative 1, 7, and 5. And what you'll notice, okay, is we've now eliminated 2 of those red numbers, right? Because we needed this one to be a 0, this one to be a 0, and now we need Mr. 6 here to be a 0, okay? Now, when I finally get to this point, okay, where I've made these right here zeros, okay, these green ones zeros, I have to go ahead and use row 2 to eliminate the final 0 in row 3. So let's go ahead and do that. So I've got row 2 plus row 3. Now, where is the 6 located? What row? Well, it's located in row 3. Now, looking at this right here, once again, we have that issue of, well, Mr. Farmer, negative 1 plus 6, that's not going to cut it, okay? I'm not going to get 0, and you're right. What we have to do is we have to take that negative 1 and multiply him by a 6, okay? Now, before we start plugging in numbers, let's go ahead and plug in what we're not eliminating, right? So we're not eliminating the top row, so I've got 1, 1, negative 1, 4, 0, negative 1, 7, 5, but I am eliminating from row 3, so I'm going to leave it blank. So let's plug in our values. So the first one is really easy because I have 6 times 0 plus 0 equals what? 0. That's not bad. But then I have 6 times negative 1 plus 6. That equals 0. And then I've got 6 times 7, okay, plus 0. That equals 42. And then I have 6 times 5 plus 12. And that also equals 42. So looking at this right here, I'm going to take what I just solved, take all these numbers right here, okay, and I'm going to plug it into this row. Okay, so I've got 0, oh, and I'm going to change back to my color. 0, 0, 42, 42. And finally, after a long-awaited journey, okay, we finally have our 3 zeros, okay? So now we are officially done with this matrix, okay? And we're now going to use the information from the matrix to solve for this system of equations. So, remembering how we plugged in the information, right? These numbers were coefficients, right? They were the numbers in front of the variables. And if we think back a little bit, this first row was x, okay? And I'll go ahead and use a different color so that way see it right away. This one was x, this one was y, this one was z, and of course this final one was just a number. So if we go ahead and retrace our steps, okay, this is going to be a 42, and what's next to it? Well, z is, right? Now, it's going to be equal to 42. Now, we can figure out what z is by dividing by 42 on both sides. And we get z is equal to 1. So that's one piece of information that we need. Now we're going to use the second row to find y, okay? Now remember, okay, these are coefficients, right? These are numbers that go in front of our variables. So, of course, for this next one, I have a negative 1y plus a 7z equals 5. Now, we're going to plug in what we know. Now, I don't need that negative 1 there. I can go ahead and just say negative y plus 7. And I know what z is. Z is actually just 1. So now I have 7 times 1, okay, that's just 7, is equal to 5. Well, if I subtract 7 to both sides, I get negative y is equal to negative 2. So y equals 2 after I divide by negative 1. Go ahead and box that better. There we go. Now I've got 2 pieces of information. Now I need my third and final piece, okay? And we're going to use that very top one, row 1, to solve our last variable x, okay? So I have 1x plus 1y minus 1z is equal to 4. Now, if those ones are bothering you, you don't need to have them there. You can go ahead and just do this, okay? In fact, I encourage it, okay? And it makes things a little bit easier to work with. And so now let's plug in what we know. Well, we don't know x, but we do know y. That's a 2, right? And then we have minus z. We do know z. It's a 1. And now we simplify. All right, so what is 2 minus 1? Well, that's going to be just a plus 1. And then we subtract 1 to the other side, and we have x is equal to 3. So now we have found our 3 variables, and we can write our system, or not our system, but our coordinate point, which is going to be 3, 2, 1. And that is the long-awaited answer right there. So this could take place of using elimination or substitution, okay? Basically finds the same exact thing. So it's really just a matter of now, what makes you the happiest? Do you like the matrix? Do you not like it? If you do, use it. If you don't, you have other options, right? So this right there, that is the end of the video, and let me know if you guys have any questions. Alrighty, bye.